Right, today we are starting factoring polynomials, which is one of the best topics ever. I love factoring. I'm also kind of a math nerd, though, so. All right, so we'll start easy. What is the greatest common factor? Can somebody describe that in words? Stacy.
Like the largest number that can be taken out.
Good, very good. Everybody give it up for Stacy. So the largest, would it be safe to say the largest number and or variable or combination of the two, now that we have letters in there? So the largest number slash variable that can be, what's the matter? Divided.
Really small.
Maybe this one. Okay. Is it better? Okay. That can be divided out of multiple terms. Okay. Whole terms. Which, by the way, what does factor even mean? Kashni. To take out. Good. Or, very good. Everybody give Kashni a round of applause. Okay, factoring is, it's like a code word for divide into parts. Okay, so we're going to start with a couple of very easy types of factoring. The first one is, let's start with difference of two squares. So this also should be a review from Algebra 1. If not, listen up. It's brand new information, so make sure you're paying attention. Difference of two squares. Okay, a difference of two squares is if we break this up into what it's saying here, difference, if we have sum, difference, product, quotient, difference is what? Sum, difference, product, quotient. Subtract, okay. So we know we have a subtraction in here somewhere, two squares, that's two perfect squares. So it's the subtraction of two perfect squares. Okay, so very general way of saying that is a squared minus b squared. What this breaks up into is a plus b times a minus b. So if we do a couple of examples, if we have, so basically you're taking the square root of the first term, square root of the last term, and they separate like this. Can anybody tell me why there's a plus in one parentheses and why there's a minus? Ashley R?
If they were both positive, then it would end up positive. If they were both negative, no.
Excellent. Everybody give it up for Ashley. Alright, so she said, if the camera didn't pick it up, that if we multiply these together, a positive times a negative is the only way you can get another negative. So, if we have something like x squared minus 100, anyone want to take a guess at how that factors based on this rule? Rachel.
Would it be x plus 10 times x minus 10?
Excellent. Everybody give it up for Rachel. Okay, what if we have something like 4x squared minus 49? Then what? Marcy.
Would it be 2x plus 7 and 2x minus 7?
Excellent. Everybody give it up for Marcy. I'm going to give you guys the option, so we would be doing examples like this after the notes. If we just want to do them within each key term, yeah, that way we don't go through more examples. Does that work for you guys today? Okay. The next one we have, so this is the general form of difference of two squares. The next one is perfect square trinomials. Okay. Trinomials. So what is a trinomial again? 3 terms. Very good. So this is actually something that we did yesterday when we were foiling things out, but we're going in the reverse order. Okay, so if we have something like a squared plus 2ab plus b squared, this factors or divides into a plus b squared. And then the other one is a squared minus 2ab plus b squared, and that one factors to a minus b squared. So let's do a couple of examples of that. Let's say that we have something like x squared plus, draw a line here. Okay, x squared plus 10x plus 25. Okay, so the way that you verify whether this is a perfect square trinomial is, you take the square root of the first term, square root of x squared is x, the square root of 25 is 5, and remember we have that coefficient of 2 here. So if we multiply these two together and have the middle term multiplied by 2, so x times 2 times 5, and we end up with what's in the middle, we have a perfect square trinomial. That is important because in the future we might end up with some that look like they're perfect square trinomials but actually are not. So you want to do this test. All right, so the way this would factor would be, let me put this down here. You take the square root of the first term, square root of the last term, and do x, 5, and then whatever the sign is here comes down with it. So this was x plus 5 squared. Okay, questions on that? Make sense? No? Question? Yes?
Wait, how do you figure out if the middle term is perfect?
If you take the square root of the first and last terms and multiply those square roots together and double them and end up with what's in the middle, that's the 2ab thing. Does that make sense?
Yeah.
Okay, other questions? Can I move this, or are people still working? You're fine? Okay. So then what if I have, let's do another one. X squared plus, nope, let's do minus. X squared minus 6xy plus 9y squared. So if we want to factor that, go ahead and move that. So if we want to factor this, what do you guys think? How would we test to see if it's a perfect square trinomial? Jade?
So we have to do the x, and then it would be 3y.
Good, 3y. And then if you multiply those together and double them, do you end up with what's in the middle?
Yeah.
Yeah, so x times 2 is 2x times 3 is 3y. Good?
Yeah.
So then how does that factor out? What does it look like factored?
X plus 3y squared.
Good, so x, 3y, and the sign of the middle part of it, sorry about that.
Oh, it's minus.
That's minus, yeah. All right, everybody give it up for Jade. Nicely done. Okay, let's do one more of these and then we can move on. All right, what if we've got 4x squared plus 20x plus 25? All right, so can somebody factor this for me? Kendra? Okay, good. Good, squared, cool. Everybody give it up for Kendra. Okay, now, you want to do that test kind of mentally just to check this test, to check whether it is a perfect square trinomial. We will learn another way of factoring these if they're not perfect square trinomials, but until then, that's all we're doing with that. Okay, the last one that we're going to focus on today is factor by grouping. So factor by grouping. Okay. Okay, so we have a couple of different types of factor by grouping. The first one is factor by grouping, let's call this A. Factor by grouping 2 and 2. What does that mean? 2 and 2. If we have something like y to the third power plus 2y squared plus 3y plus 6. So we typically know that we're going to use factor by grouping if we start out with 4 terms. Okay? In this first one, if we're factoring by grouping 2 and 2 together, all that means is we're going to group the first 2 terms together and the last 2 terms together, and then factor those individually. So the first group is y cubed plus 2y squared. So within that first group, what is the greatest common factor there? Good, y squared. And when we factor out y squared, what are we left with? Y plus 2, good. Okay, how about in the second group? We have 3y plus 6. So what do we factor out there? A 3, good, and we're left with? Y plus 2. So what I'm hoping you all notice, what we did is we factored out what these 2 terms had in common. Well, now we're factoring what these have in common. They both have a y plus 2 in common, so that gets factored out of both of them. So or if you want to look at it this way, the y plus 2 gets its own set of parentheses, and then what's left over gets its own set of parentheses. So y squared plus 3 goes over here. Okay, questions on that? Oh. Thank you. Okay, questions on that? Does it make sense? Yeah? Okay. Do we want to do another one of those, or are we good? We're good. Okay. Are we good? Can I move it? Yeah. All right. Last two. Factor by grouping 3 and 1. By grouping 3 and 1. And then the last one is going to be grouping 1 and 3. Okay, so here we go. We've got something like x squared plus 6x plus 9 minus y squared. So factor by grouping 2 and 2 meant we grouped the first two terms together and the last two terms. So what do we think factor by grouping 3 and 1 means? Let's take a wild guess. Kendra? That's good. The first 3 and the last 1. Everybody give it up for Kendra. All right. Now, here's how we're going to go about this. I'm going to cover part of this up because we're going to break it up into a couple sections. The first group, does anybody recognize that as being anything we just talked about earlier today? What do you think? Stacy? Good, a perfect square trinomial. So what is x squared plus 6x plus 9 factored? All right, everybody give it up for Stacy. All right, I'm going to do a little sidestep over here, okay? From this, let's suppose I had something like x squared minus y squared. Can somebody tell me how I might factor something like x squared minus y squared? This is a difference of two squares. We go back to our difference of two squares. Like the x squared minus 100 thing. Whoop, we're getting dim. Okay, so something like this. What do we think? Akashni? X minus y. Excellent. Everybody give it up for Akashni. Okay, so what is the only difference between x squared minus y squared and what's over here?
3.
The plus 3. Okay, so here's how I'm going to go about doing this. We're going to set up some big parentheses. So we can, if I just cover this up, the plus 3, then I can say that the factored version of x squared minus y squared from over here is x plus y and x minus y. I'm leaving a big space in there, because what do you guys think goes in that big space?
3.
The plus 3. Good, okay, we're actually, let me put some little parentheses around it, which doesn't make a huge difference in terms of this problem, but in the future it will. Does that make sense to everybody? Oh, okay, cool. So I can actually just take the parentheses off in this case, but the one that we're about to do, those parentheses make a huge difference. Are there questions on that? Okay, last one. And then you guys can work on your homework.
Is that the answer?
That's the answer, yep. Last one, factor by grouping 1 and 3. Okay, so this one, let's see, do y squared minus x squared minus 6x minus 9. Let's think about that for a minute. Okay, so what do we think this one means as far as grouping is concerned? 1 and 3. Hannah? Good, first one, last 3. This is one where we're actually going to group by parentheses before we start factoring things individually. Why do you think we might do that in this case? Why would we want to maybe put the x squared 6x 9 all in one set of parentheses? Any ideas? Akashni? Okay, we can do that. So notice too that they all have a negative in them. So if we factor that negative out, what happens to the x squared 6x and 9? They what? Cool. X squared plus 6x plus 9. So, what do we say x squared plus 6x plus 9 factors to? X plus 3 squared. Y squared minus x plus 3 squared. And now we're back to, whoops, if I ignore that plus 3 and I have, just like we did over here, y squared minus x squared, can someone tell me how they think that might look factored? Keeping the parentheses on. Again, if it was, Rachel, go ahead.
Y plus x plus 3 times y minus x plus 3.
Cool. Everybody give it up for Rachel. y plus x plus 3, y minus x plus 3. So we did the same thing as what we did on the last one. This is where keeping those parentheses in makes a difference. Why do those parentheses make a difference on this, but they didn't on the last one? Does anybody see anything within here that would make that important, Ashley R?
Because there's a difference between negative x plus 3 or minus x plus 3.
Okay, good. So what do I have to do with that negative sign? Very good. All right, everybody give it up for Ashley. So do the parentheses on the first one matter? No, so I can just kind of get rid of them. But this one, it's y minus x minus 3. Okay, how are we doing on questions? Okay, we're done. Homework 30, page 199, written exercises 18 to 78, multiples of 3. All right.